Now let's talk about normal probability distribution. Let's take a look at the normal probability distribution definitions, requirements. First, it's a probability distribution for continuous random variable x that can assume any values such that mean, mode, and median, they're all equal. The mean, mu, and the standard deviation, sigma, are given in the problem. The graph of the distribution is symmetric and is bell-shaped. The total area under the curve is equal to 1. Probability that x, our continuous random variable, is equal to a specific value c, that probability is 0. And probability that x is between two numbers is the area under the curve over the interval a to b, as is displayed here, and the gray area represents the probability that x falls between a and b. A commonly used notation is n with the parentheses mu comma sigma. N for normal distribution, mu for the mean, and sigma for standard deviation. How are we going to deal with normal probability distribution using TI? So this chart helps us to find the probability using the TI command normal CDF that takes four values: the lower, upper, mean, and a standard deviation. We used e to the 99 for a very large number, and we use negative e99 when we need to have a very small number. Let's find the probability that x falls between 26.5 and 32 given a normal distribution with the mean of 30 and a standard deviation of 2.5. We're going to draw the normal curve. We're going to shade it and label it accordingly. This shaded area represents the probability. We're going to use our normal distribution chart and use the TI command normal CDF. Our left value is 26.5, right value 32, mean 30, and a standard deviation 2.5. So that probability is 0.707. We want to find probability that x is greater than 45, rounded to the nearest whole percent, given a normal distribution with the mean of 40 and a standard deviation 5. Once again, we're going to draw the normal curve, shade and label it accordingly. The shaded region here represents probability that x is greater than 45. Using the TI command, the lower value is 45. The upper value is E99. The mean is 40 and the standard deviation is 5. So we're using normal CDF. The answer is 0.159. Rounding it and converting it to a nearest whole percent, we get approximately 16%. Now let's find probability that x is below 70 rounded to 3 decimal places given a normal distribution with the mean of 85 and a standard deviation of 7.5. Again, we're going to draw the normal curve, shade, and label accordingly. Using the TI command normal CDF, our lower value will be negative E99, upper value 70, mean of 85, and a standard deviation of 7.5. Rounding the answer to 3 decimal places, we get 0.023. Now, in this example, we want to find probability that x is below 190 or x is above 210 given a normal distribution with a mean of 200 and a standard deviation 10. Once again, we're going to draw the normal curve, shade, and label. We can find the two probabilities and add them together, or we can subtract in between from total probability 1, and that will give us the same result. So probability that x is less than 190 or is greater than 210 is the same as 1, the total probability, minus probability that x is between 190 and 210. Using the normal CDF command, our lower value will be 190 and upper value is 210 with a mean of 200 and a standard deviation 10. And the final answer is 0.0317. Now it comes a time that the probability is given and we need to find the value that gives us that probability. And how do we do that with TI? So if the probability of x is less than k, that means the left area is given. We want to figure out what k is that gives us that area. And in this one, we're just going to use inverse norm, one of the TI commands. And with that, first we need the left area, which is the probability that x is less than k, and then mu, the mean, and a standard deviation sigma. In this example, we want to find x equal to Q3, the third quartile, rounding it to a whole number, given that we have a normal distribution with the mean of 6,200 and a standard deviation of 400. Well, we already know Q3 simply means that the area to the left is 75% and the area to the right is 25%. So we're going to draw and label again. So we have the left area as 0.75, the bottom 75%. We also have the area to the right, the top 25%. But using inverse norm, we just need the left area. So x equal to Q3, using inverse norm TI command, with the left area of 0.75, mean of 6,200, and a standard deviation of 400. Rounding it to a whole number, we get 6,470. Now, what if the probability that x is greater than k is given, and we're supposed to find k using TI? So now we have the probability on the right side, probability that x is greater than k. So the left side is 1 minus probability that x is greater than k. Once we have the left area, then we can use the inverse norm. Using the left area, followed by mean and standard deviation. In this example, we have a normal probability distribution with the mean of 130 and a standard deviation of 12.5. We want to find k such that probability that x is greater than k is equal to 2.5%. When we convert 2.5% to decimal notation, we get 0.025. But this is the area to the right of k. So if we draw and label and find the area to the left of k, will be 0.975. That area was to the right of k because the probability was for x greater than k. Now using the inverse norm, left area 0.975, mean of 130 and a standard deviation of 12.5. The value for k will be 154.5. I hope this presentation helped you understand normal probability distribution.